Hi folks, see you speaking again. Today we're going to have a nice and very simple application actually. A basic one, counting items using this kind of photocell over here. Counting items we want to pack in a box. We're going to do that simulation considering, let me make it more quiet. We're going to count these items supposedly to put in a box, and the box is going to be picked up by the conveyor and moved away. Let's find out what are the controls, because the first part is an application, we call it software programming. Why software programming? Because the wiring is already made, we don't have to modify any of the wires, and if a modification is required, we only need to go in the program, which is going to be magnified right here on the screen, and you only modify the instructions, but the wiring remains the same. And in the second part, we go to hardware programming, where every little modification we want to make, we have to modify wiring. Let's start it. Here are the controls. I have here a green and a red button. So anytime I'm going to press any of them, it's going to be signaled by this light between them. So let's say this is going to be the start and the stop of the whole operation. So if it is a stop now, whatever else I'm pressing, like here, I'm actuating the sensor because I keep my finger in front of it. Anytime the item is counted, you're going to see a light over here. Later on I'm going to show you there are some lights on the sensor, but let's imagine the sensor is hidden underneath the conveyor, so you or masked somewhere on the conveyor, you won't see the little lights on it. So then we put an external light to see if it's doing the job. And just to make sure for the troubleshooting purpose, supposing you may have something on the sensor to see if the rest is working just fine, we're going to have this green button here. You can hear the relay, it actuates, and this green button is going to simulate the same thing as the sensor, like they were put in parallel, so you can use either the sensor or the green button. Let's suppose we want to pack in that box 7 items. So for that reason, I put here a counter. You can see the mnemonic for the counter CMT, and here the #7 means this is the set value. Now, I'm going to tell you a little secret about this kind of counters. If you want to count up to any number, not necessarily to 7, it may be 8, it may be 15, whatever number you want. So if you want to count up, in the moment you reach the number you want, you have to have something like a decoder to sense the binary combination corresponding to the decimal number, and then to reset the counter to bring it back to restart. The secret is, if you count down from any number you set, you are going to reach 0. So the 0 is going to be the same starting from any number you want to count. This is why the most common simple applications, they are based on counting down. And I'm using here for the demo a Omron PLC. So for Omron PLCs, there are several kinds of counters, but the standard counter is counting down. So you have now a reason why the counter is counting down, because it's the easiest way to have a decoder, okay, for the number you want. So here you have the set number to 7, and here in the top you have another 7 in BCD. You remember what is the BCD code? Actually for us it means decimal. This is going to be actuated anytime we count the items. So it's going to be the track, is tracking the number of items dropping in the box. Let's start it. So first move is what? Put it on. And when I put it on, anytime I'm counting, let's make a simulation with this one. You take a look what happens to the counter. 6 remaining, 5, 4, 3, 2, 1, and now it's gonna reach 0. I'm simulating the conveyor by this geared DC motor, because it's making a noise similar to a kind of buzzer, if you want. So it's the same thing, the motor and the buzzer. Okay. So now I can stop it and take a look what happens on the screen. In the moment I press the button here, I'm going to bring the counter back to the number I want to count. So in the moment I have the 7 items in the box, the conveyor moved by that motor. Remember, the conveyor is converting the rotational move of the motor into a linear one, okay? So when the conveyor is taking the box out, it's taking it away, then by actuating that switch, I'm setting the value back in the counter so I can restart again. Now I'm going to do this with the cell. So you take a look. It goes to 6, another pulse, 5, 4, 3, 2, 1, and now the conveyor is moving it, you see? And the number goes back there. And let's suppose I'm not happy with the number 7. No big deal. I'm going to stop the program. I'm stopping the program. Now I can modify the number into the counter. It's a command called edit, okay? So I'm going over there, and instead of the 7, I'm going to put a number, let's say 12, okay? So you see now the number here inside is 12. I'm connecting again my computer to the PLC, because any modification you want to make is actually you modifying the program. So because of this, you have to send it back to the PLC. This is what I'm doing now. So right now the program, as you can see, is transferred back into the PLC. It won't take longer than 10-20 seconds. You see, now it's done. And now we put the PLC back into the run mode. Let's get rid of the display showing me the outputs. Don't need that. See? So now we have 12 items. So anytime I count right now, either from the cell, I'm counting items. See? Nothing happens. Why? Because I have to restart the program. So the restart is from here. And take a look. I restart the program. It goes anytime I pass my hand in front of it. Doesn't matter what direction. And now the conveyor picks up the box. I reload it. But one more thing. Let's say I'm simulating it. To from here. I can continue from here. And let's suppose here, by pressing the red button, I'm stopping the program. So by stopping the program, take a look. Whatever I do, there is no more modification. Either here, if I put my hand in front of the sensor, or here, if I try to simulate this by using my green button, nothing is working because it's stopped. And the counter has an interesting property. They say that the counter is retentive. It memorizes where it left. Why? Because let's say in the box is designed for 12 items. And if it stopped at 5, 7 are already there. If you restart from 12 back to 5, there are 7 items, plus 7 already there will make 14. It's going to be an overflow. You don't want this to happen. This is why the counter retains the value where it stopped. But when I put it back on, take a look by the green button. By pressing the green button, nothing happens over there. But now I can continue counting. Take a look. Exactly where it left. And now it's going on. Okay? So, conveyor is stopped. The number is reloaded inside the counter. This is how it's working. And now let's see the same kind of operation if we do hardware programming using our electronic integrated circuits we already studied previously.